Geobyte.
Look at this problem. Asking like this. A bullet is fired at time t equal to 0 with velocity 20 meter per second. U equal to 20 meter per second and at an initial angle of 30 degrees with horizontal. Initial angle with horizontal it is given. This is horizontal direction. With respect to horizontal, the velocity u is given 20 meter per second at an angle theta is given 30 degrees. The angle between the displacement vector and the horizontal after time t equal to point 1 second. So the angle between the displacement vector and horizontal. For that what you need is you need to decide the horizontal component of velocity ux, right? Or horizontal velocity is given. Let us decide the horizontal displacement. Horizontal displacement x equal to velocity along x direction multiplied by t. Velocity along x direction is 20 cos 30 multiplied by zero point 0.1. So x equal to 20 cos 30 root 3 by 2 into zero point 0.1. It is equal to 2, it is 20 into 0.1 2 by 2 into root 3 equal to root 3. That is x. Similarly y value, right? Y equal to velocity along y direction into time minus half into gt square of gt square. Velocity along y direction equal to u sin theta. What is the u value? U 20, theta 30. 20 sin 30 minus into t how much? 0.1. T equal to 0.1 minus half into g 10 t zero point 1 whole square. It is equal to 2 into sin 30 1 by 2 sin 31 by 2 minus 5 into zero point 0.1 whole square. Zero point 0.1 whole square it is equal to 1 minus 0.205 equal to 0.295. 0.95 I can write as 19 by 20 meters. Then tan, let us say alpha, tan alpha equal to y by x. Y by x. Y equal to 19 by 20. X value, how much you got? X value root 3. X value root 3. So 19 by 20 root 3 is the right is the what the angle between the displacement vector and horizontal after time t. So 19 by 20 root 3 option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. Asking like this. A man walking along a straight line with a velocity 6 km per hour encounters rain falling vertically down with a velocity 6 root 3. Velocity of the rain 6 root 3. It is falling vertically downwards. Vertically down. The man is walking with a speed 6 kilometer per hour. Of course, it is also 6 root 3 kilometer per hour, right? In a straight line. Straight line. At what angle the man should hold his umbrella so that he can protect himself from rain? For protecting from the rain, at what angle the umbrella must be kept? That is the question. Here it is given with respect to ground and with respect to vertical also. Let us take the straight line. Let us say the man is keeping the umbrella in this particular direction at an angle theta with respect to horizontal. With respect to horizontal, here horizontal velocity is given, that is man velocity 6 km/h, whereas the vertically rain is falling vertically with a speed 6 root 3 6 root 3 km/h. Okay, then what is the tan theta with respect to horizontal? With respect to ground, horizontal means ground. With respect to ground, with respect to ground, tan theta equal to what? Opposite side. 6 root 3 divided by 6. 6 is cancelling. It is root 3. Then what is the theta with respect to horizontal? Theta equal tan inverse root 3. That is equal to 60 degrees. With respect to ground, it is 60 degrees. 60 degrees. If the option is available with respect to vertical, with respect to vertical, let me mark here. With respect to vertical, the theta with respect to vertical equal to 90 minus theta with respect to horizontal. It is equal to 90 minus 60 equal to 30 degrees. So the umbrella must be kept at an angle 30 degrees with respect to vertical or 60 degrees with respect to ground. Okay, or 30 degrees with respect to vertical. Now look at the options. Look at the options. Option A, 30 degrees with respect to ground. No, 30 degrees with respect to vertical. Absolutely correct. 30 degrees with respect to vertical. Absolutely correct. Option B is absolutely correct. Understood clearly? Yes. Similarly, look at the another important problem. It is asking like this. An aircraft is flying at a height of h above the ground and at a speed of v. The maximum angle subtended at ground observation point by the aircraft after time t. Very simple. Let the ground. There is the ground. Assume the flight is flying from this point to in this particular direction. Now the no flight is traveling with a speed v. Flight is traveling with a speed v. After a time t, no, the flight is starting from A at a height h and is moving towards B. The distance traveled AB equal to x and angle subtended with respect to vertical is theta. Then look at the tan theta. Tan theta equal to x by h. But x equal to what? X equal to velocity multiplied by time. Time taken to reach the B from A is given as is it given t? Yes, t. So x equal to Vt divided by h. Then angle equal to tan inverse Vt by h. Tan inverse Vt by h. Look at the option A. Option A is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. Asking like this. A merry-go-round rotating at a constant angular speed completes 9 rotations in 18 seconds. What is its angular speed? You know, for completing one rotation, for one rotation, for one rotation, for one rotation, right? Angle theta equal to 360 degrees equal to 2 pi radians. Radians. But it is completing 9 rotations in 18 seconds. The total angular displacement equal to 9 into the angular displacement for one rotation, 2 theta. Therefore, angular speed omega equal to angular displacement dividing by time taken. Angular displacement 9 into 2 into pi dividing by time taken is 18 seconds. 18 cancel. Pi radians per second. That is the angular speed of the merry-go-round. Pi radians per second. Look at the option B. Option B is absolutely correct. Understood clearly?
Geobyte.